We're going to keep talking about energy, and in the last video I left you with the question that if I fire a cannon directly upward, we're ignoring the effects due to the air here, but as the cannonball leaves the cannon, it has a certain speed, which means it has kinetic energy. Remember, kinetic energy is the energy of moving objects. But when this cannonball hits the top of its trajectory, it stops for a second before coming back down. My question was, when it stops, if all energy is transformed from one form to another, what happened to that kinetic energy that that cannonball had? The answer to this is that it turned into what we call potential energy. And in classical physics, you can roughly think of this energy as stored energy. Specifically here, we're dealing with gravitational potential energy, and it has to do with an object's height. Specifically, gravitational potential energy is an object's mass times the acceleration due to gravity, variable g, times the object's height. But for our purposes, in this case, those first two variables, m and g, don't change, so it really depends on the height of this object. Keep that in mind. Now let's go back to our cannon example. I'm going to set the height of 0 right where the cannonball leaves the cannon. So as the cannonball leaves the cannon, it has its maximum speed, so it's going to have its maximum kinetic energy, but its height there is 0. So it has no potential energy, all kinetic energy. As this cannon reaches the top of its trajectory, though, it stops for a second. At that point, the cannonball speed is 0, so it has no kinetic energy. But at that point, its height is also maximum. So that's where this potential energy is maximum. You can see that all that kinetic energy was transformed to potential energy. Of course, the cannon's going to come back down. Gravity exerts a force on it. So when it gets back to that height of 0, it's going to have regained all that kinetic energy that it had.